So, task 3 of Austrian Mathematical Olympiad, my friends. Let us start. We consider the following operation applied to positive integer. The integer is represented arbitrary base, which is exactly 2 digits, and then in both digits are different from 0. Okay, then the 2 digits are swapped and the result is base b. In base b is the new number. Is it possible to transfer some great numbers to some small numbers? So what does it mean? For example, if we take some number, I don't know, 17, base 10, we convert it to some other base. For example, base 5. If we take it base 5, or let's see what we have. It is 3 times 5 to the power of 1 plus 2 times 5 to the power of 0. So it is 32 in base 5. And what can we do? We can swap these numbers. So it becomes 23 base 5, which is a smaller number. 2 times 5 plus 3, it is 13 base 10. Okay, so the number got smaller, and so that is what we need to do. We need to get each and every number smaller than it was. Sometimes it is not so easy, like for example, if we take 18 base 10, we see that this could be like base 12. What is it, base 12? It is 1 times 12 plus 6. So it is 16 base 12. And yeah, if we swap it, it becomes 61 base 12, which doesn't look nice. So we have to look very careful whether we can or we cannot reduce each or every number. So we get them smaller, and so in each step they get smaller and smaller. And if we invent the procedure that can consistently give us smaller and smaller numbers, then that's okay. So let's do it. 17 base 10, we can do it like, what could be, let us think, what could be the greatest base so the number would reduce substantially. If we do it like 2 times 8 plus 1, which gives us 21 base 8. You see, there is something ending with 1. So we swap it and it becomes 12 base 8. So we reduced it almost 2 times. And this is 8 plus 2 equals 10 base 10. And this is what we wanted. So it worked for 17. Let us see if it works for each odd number. So 2k plus 1 base 10 equals, what is this number? This number is precisely k. So it is 2 times k plus 1, still decimal. It becomes 21 base 10. We swap the numbers as we are allowed. It becomes 12 base 10. So it is much smaller already. And what is 12 base 10? It is 12. It got smaller. Just simply 12. Yes. Sorry, here it goes to be base k, and here again base k, and here it is base, what is it? We need to convert it to base 10. So it becomes 1 times k. Yes, 1 times k plus 2. I will not re-record. I'm lazy. I'm just doing it from the very first recording. So it is k plus 2. And obviously base 10. Base, base 10. And so we see obviously that k 2k plus 1 is obviously greater than k plus 2 for all reasonably big k. And so this is procedure works for all odd numbers. What do we do? The question remains. So we can reduce odd number to something smaller. So what do we do with the even numbers? So even numbers, guys, it looks like probably a long explanation to you, but you see, it's easy to just show you, this task is done this way. But no, this is not how it works in real life. This is not how you will approach it on the Olympiad. Because on the Olympiad, you're like, what I'm going to do? Do I want to do this or that? And you explore various opportunities. This is what we do here. We kind of try to understand why does it work like this and how are you supposed to think. So even numbers. Right. Oh yeah, just got an SMS. Yeah, that I'm getting money soon. Not bad. So it should improve my mood. Okay, so even numbers. Even numbers. Let's try some number. We tried already 18. It doesn't seem to work. If we try to do something like 2k number, or let's go with 20 ends with 0, but no, it's in decimal, ends with 0 in some other base. What could be other base? If we do it like, I don't know, base 11, something greater than 10, it becomes 11 plus 9, so it is 19 base 11, and if we swap it, it becomes 91 base 11, which is very big. It doesn't look like nice. Although it's odd, we can just later on nearly half it by this procedure, but appears to be hard. Then what do we do? Like 20 base 10, we can convert it to if we take some greater base than 10, like 12, 13, it will be 1 and something. When we swap it, it becomes something and 1. Doesn't look like very good. If we take something small, like base, I don't know, 6, it becomes 32. Yeah, we can convert it to 23, but there is no ways to just make it systematic. So what can we do? And I tried many different ways, they didn't work. So what can we do? We can say this is, I will continue here. We can say it is 20, base 10, and I convert it, I make it not 19, but let's make it 12. So immediately going down doesn't work. So let us go up a bit. So 20 base 10, I will convert it to base 8 of, what is it, 2 times 8, 16 plus 4. No, not good. 24 or maybe base 9. Base 9 could work. Base 9, I make it 22 base 9. No, this is not good, because if we swap 22, it's not going to be good. So I take base 8, I make 24, which is not that bad. We can swap it, and actually we can make matters worse. 42 base 8, which becomes 4 times 8 plus 2, 32 plus 2, it is 34 base 10. And this is kind of not so good. So am I right? 2 times 8, it is 16. 16 plus 4. No, I want here to have 1. So again, not very good. Not good. It's not wrong, it's just not good. So I want here this number to be 1. I want, when I swap, I want an odd number. So let's make it 20 base 10 equals, if we make a base of 19, it becomes 11. Not very good. So because we can't swap it, so let's make it base 18. And this is what? 1, 2. 1, 2. and then we swap it, it becomes 21 base 18. And so this is 2 times 18 plus 1, which is 36, 37 base 10. Yeah, number got bigger. And then if we make a lowering procedure like this one, 37 base 10, yes, equals, we take base k. What is k here? K is 18. So it becomes 21 base 18, and we just repeat the reverse, and so on and so forth. It becomes back 20 base 10. Not very helpful. But let us try, maybe we can see something about this number 20 with the k, which we do not see here. So going backward and forwards is not very helpful. So what do? We, instead of 20 base 10, let's say it is 2k base 10, and if we go to 18, 18 is 2k minus 2. Then again it becomes 1, 2. You can check it. 1, really, yes. 1 times 2k minus 2 plus 2 actually equals 2k. So then we swap it. It becomes 21 times 2k minus 2, and it is 2 times 2k minus 2 plus 1 equals 4k minus 4 plus 1 minus 3. Aha! So this is the number. We kind of know what is it, modulo 4. And we can try to use it, like this is base 10, obviously. We can try to use it. So let's make the remainder even smaller. We convert it to 4k minus 1, 4k minus 4 plus 1. Yeah, all base 10. I will skip base 10. And for this, it is easier for us to do the next step. So the next step is 4 times k minus 1 plus 1, like base 10. We convert it to easily 41 base k minus 1, which we can swap, and we can do it easily because 41 something big 1, and we swap it, we become we get number much smaller, nearly 4 times smaller. Yes, and in decimal it is 1 times k minus 1 times 1 plus 4 equals k plus 3. K plus 3, yes, base 10. Okay, and so what did we do here? When we did like one step back, we nearly doubled this number from here to here. But when we did the next step from this odd number, not some odd number, but odd number, we know what is it, base 4. We kind of reduced it, divided it by nearly 4. So lose by multiplying by 2 and gain by dividing by 4. So this number is less. And so 2k is obviously greater than k plus 3. And we know, since the number is greater than 10, that if k is greater than 5, it works. So we constructed a procedure for even numbers. So what do we do with even numbers? First, we do it like this. We move to 4k minus 3 base 10. And then it is step 1. In step 2, we convert 4k minus 3 base 10 to k plus 3 base 10. And for odd numbers, the procedure is here. So we know what to do with odd numbers. It's one step. We now know what to do with even numbers. There are 2 steps, step 1 and step 2. So we know there are no other numbers beyond odd and even numbers, as you know. And so with each step, we get our number smaller, and we can repeat this procedure infinite number of times. Even if our number base 10 is big one, we can still make it 2-digit number base b. And this finishes everything. Guys, if you have questions, if you want me to explain more clearly how do we convert from one base to the other, because this is a Olympiad level task, the listeners normally are supposed to know some basics like convert from one base to the other. But if you want to know how to do it, if you want to prepare for Austrian Mathematical Olympiad, then let me know. I will explain you some simpler details. Yeah, thank you. Good luck with your Olympiad. Have a nice day. Goodbye.